Hello and welcome to the IoT Central Dev Board Roundtable. My name is David O'Hara and I'm the Managing Director at IoT Central. Today's event will be an hour long and I'll introduce our hosts and panelists in just a moment. We'll be having a Q&A session after our panelists speak. You can submit questions in the control panel. IoT Central is a global community for IoT practitioners. Joining is free upon approval, and our content consists of member posts providing a rich peer-to-peer community. If you're not a member of IoT Central, I recommend visiting iotcentral.io to join. Now let me thank ARM as our host sponsor and panelists from 96 boards, Arduino, NXP, and Qualcomm. From Arduino, we have Dario Pennisi, Hardware Development Manager. From Qualcomm, we have Rajan Mistry, Senior Engineer. From NXP, we have Rick Bai, Senior IoT Solutions Marketing Manager. And from 96 boards, we have Sahaj Sarup, Applications Engineer. I would like to introduce today's hosts. Alessandro Grande is the Ecosystems Manager, Automotive and IoT at ARM. He's a human-centric technologist who focuses on driving innovation by supporting a diverse range of developers building solutions in IoT, embedded, robotics, drones, machine learning, and security. During this last year, Alessandro has been focused on building a thriving online community of software developers. Robert Wolff is Manager, Ecosystem Developer, Evangelist at ARM. He's a technical writer, open source evangelist, community leader, and studied engineer with a history of working in and around esteemed academic institutions and STEAM-based educational programs. He helps maintain several open source repositories, runs a global Discord server with thousands of developers, and moderates the ARM Software Dev Twitter channel. Now, for the co-hosts of the weekly live stream Innovation Coffee, Alessandro and Robert, take it away.
Thank you, David. Thank you. That was an awesome introduction.
Yeah, thank you, David, very much. Very excited for this. And thank you, everyone who's joined us today, all the viewers out there. Very excited to get this going.
Yeah, I'm really excited to be here today, Robert. And I get to hang out with you, my favorite co-host, and with a lot of guests today. So I'm doubly excited. And so, guys, today we're going to talk about a little bit of history. We'll give you some context around what the show is about, and we'll give you our 2 cents on how to pick the best development board for your project. Robert, did I cover the intro? And I think you want to go first, right?
Yeah, looking good, perfect. Yeah, so as Alessandro mentioned, I think what we first want to do here is cover a little bit of a history as to how did we get to this point with these developer boards, because we are talking about choosing the developer board for your project sweet spot, right? But not too long ago, and this is, I'm talking about a decade ago, you really didn't have so much access to developer boards as you do now. Lead times were somewhere between 6 weeks and 6 months. And by lead times, I mean the amount of time it took for you to place your order for your board, for it to show up at your desk. Not only that, if you were looking to find a relatively inexpensive board or something to kind of play around with or test on, you were still going to spend thousands of dollars. It wasn't until the maker movement and some of these pioneering companies like Arduino and Raspberry Pi, 96 boards, that paired up and teamed up with some of these amazing chip makers to create higher production of boards, more boards at a more inexpensive cost, getting them into the hands of developers. So back in the day, again, you couldn't get boards very easily. They were more expensive. Now you can get boards for $20, a few dollars. So it's pretty amazing where things have gone, Alessandro.
Yeah, I mean, I totally remember that turning point, right? I was at university and I remember talking to a colleague and he shows me his project and he was building a telescope driven by an Arduino, right? And at the time I didn't know what Arduino was. So he comes up to me, he shows me, his project, and he starts talking to me about this board. And in my head I was thinking, okay, this is probably going to be a few hundred of dollars, but actually, he says it's only a few dollars. And not only that, but he shows me how easy it was to program, right? And that was really the moment in which I started looking at embedded more seriously. Up to that point, I used to only program in assembly, so it's completely a different world, right? And that really opened my eyes. So yeah, I mean, that was an interesting point in my history.
Yeah, I actually have a similar story. So in my alma mater in college, I think this was like 2012, maybe right when the Raspberry Pi was coming out. One of my buddies walks into the lab and he's just like, kicking and screaming, "You won't believe it. There's a $25 developer board, a single board computer, a full blown computer." And I'm just like, I don't buy it, right? I didn't believe it. He tries explaining things. I'm like, "Can you hook stuff up to it? Can you hook your keyboard and your mouse and a monitor?" He's like, yeah, all that. It's a full computer. Sure enough, we go to his place after class, and I walked away with a $25 full-blown computer. And this was, of course, the first Raspberry Pi. And so, of course, since then, the explosion of developer boards, and that's why we're here to talk about choosing these boards, because there are just so many now. Back then, it was kind of easy. Now it's getting a little difficult.
Yeah, and I mean, we talked about the beginning, right? So that was when the explosion started, because then there has been, as you said, an explosion in the number of boards and the types of boards and in all the features that all the different boards have, right? So, as you said, the reason why we're here today is to actually, with our guests, talk about, how we can help you to choose your development board for your project. So, Robert, to get started, what are the first questions that you would ask yourself, or you ask yourself when you go to pick your board for your project?
Yeah, so I'm not going to have enough time to go through all of the questions I would ask myself personally. I mean, when you're building a project or when you're testing something, you're going to think about all sorts of stuff, right? But in general, once you've decided on what your project is going to be, you need to kind of assess what type of chipset you want to use, right? So how powerful do you need your chipset? What other specifications might you be interested? Do you need more memory, et cetera, storage space? And then also you got to look at peripherals, right? I mean, do you need to hook up a keyboard, a mouse, a monitor? Do you need access to more IO? What types of IO do you need? And so these are all kind of questions that you're going to need to ask. And our guests that we have on today are hopefully going to clarify and show you all sorts of different boards with all different types of peripherals, software enablement, and all sorts of cool stuff that you'll get to explore here. So, but before we do that, we have two things here, MPUs and MCUs. And I want to talk about this a little more. So I'm going to allow Alessandro to elaborate a little further on the differences between MPUs and MCUs and how it applies to the different boards that we'll be looking at.
Absolutely. I think, yeah, there is a lot of boards out there, but actually, the complexity is even it's even greater because there is a big choice in the CPU itself, right? So, I have to admit though that it's not so easy to actually draw a line between the difference between an MCU and an MPU. But there are some differences that still hold today, right? So, let's start with the microcontroller unit, or MCU. Those are used for real-time applications. They're super low power, and they're constrained devices usually. Where the microprocessing unit, or MPU, has more performance, more resources, and usually cores such as ARM Cortex-A CPUs run rich OSs such as Linux. So I think those are the main differences that tend to hold most of the time. Did I cover it all, Robert?
I think you did, yeah. And I apologize, or we apologize, if that's too much of a basic lesson, but we did feel like we needed to cover it and make sure that you're all on board with that. So yeah, awesome, thanks.
Cool. So I think we are ready to do some fun show and tell here. So I've got this board with me, right? I mean, let's start from the smallest. I've got a few boards, but this is one of the smallest I've got. This is an Arduino Nano 33 BLE. And the interesting thing about this is that it's got an ARM Cortex M4F on it. And it allows you to do all sorts of IoT applications because it's got Bluetooth, but it also does, there's a lot of tutorials online of how to do tiny machine learning on this. So, check out this board, and Dario, I'm sure we'll talk more about that. I've also got this other one. Let's see if I can get it into focus. The reason why, I'm a bit biased, but I like the fact that this comes with a sticker on it that says, I can't get it in focus, that says made in Italy. So that was, I thought that was quite funny. But other than that, I've got a surprise for you, Robert. Do you remember this board?
I do. The Dragon Board 410C, probably one of the most fun boards I've ever worked with. I built a fun course at Coursera around this one. This is a quad-core A53 ARM-based board from Qualcomm with the Qualcomm chipset, Snapdragon 410E chipset, and it's based on the 96 board's specification. This is one of the older Snapdragon boards, I should say. I mean, since then, Qualcomm has worked with 96 boards to release some other ones. You have like the Dragon Board 820, the Dragon Board 600 series. You have the robotics kit board. So there's a lot of cool stuff. And I'm sure Rajan and Sahaj, two of our guests today, will be talking more about that. I have one for you, actually, Alessandro, too. So I brought this out of, or plucked it off of my handy dandy board there. This is the AI ML board featuring the NXP chipset. I don't know if you want to talk about this one.
Yeah, I mean, the reason why, I like this board because it's part the chip on there is part of the IMX8 family from NXP. And what I find interesting about these chips is that they've got both a Cortex-A and a Cortex-M on it. So you could do, real kind of real-time processing or real-time applications, but also you could have much more much more intensive applications running on the Cortex-A. So I find those really interesting, and there's a plethora of boards of that family, right, Robert?
Yes, so this is based on the 96 board spec. I'm gonna pull up two of these here. So I have the brother of this board. This is the Thor 96. And so if you look at both of these right here, you'll see that they kind of resemble each other. This is based on the 96 board's consumer edition specification, and this is actually the extended version of that. So you can see that they are roughly the same, but not quite. So this is kind of where we're talking about picking the boards that you want to use, because the chipset is slightly different. The peripherals are slightly different. This board on my right side, the blue one, has 2 HDMI ports, whereas this one only has 1. And you can kind of start to find these subtle differences. And this is what we're going to be talking about today. How do you pick the right board to hit your project sweet spot? And that's why we're looking at these things. So very cool. Thanks, Alessandro.
Yeah, so I think we're ready to go. So it's time to bring our first guest in. Dario, are you ready? Dario from Arduino. Hi, Dario. Hardware Development Manager at Arduino. Welcome.
Hi, yes, I am. So yeah, actually, I got a lot of things to tell about what we've been doing in the past few years. Actually, since I joined Arduino, that's been really very interesting, because we tried to drive the change and introduce some cool new hardware. So let's get started with that first, of course. And basically, the most interesting thing about that is we have, of course, a legacy of products that is quite extensive. And in particular, we have this range of MKR boards, which have basically every possible kind of transmission modem. So we have narrowband IoT, Cat-M1, we have Sigfox, LoRa, GSM, I mean, you name it. We even launched at some point the Vidor, which has an FPGA, which allows you to do fancy stuff. And of course, we have Wi-Fi and Bluetooth, which are very important. All these boards are complemented by the shields, which are, let's say, application boards where you can connect things like relays or other interfaces such as Ethernet or CAN or 485 for, let's say, industrial control and so on. In addition to this, we have another family, which is the Nano, which we recently revamped. It started, of course, with a non-connected board, but last year we wanted to add some spice to it, and we created these 3 boards, 2 of which are basically just assembly variants. So one is the 3.3 IoT, which basically contains a Cortex M0 plus an ESP32, so that basically allows us to have Wi-Fi and Bluetooth connectivity. Whereas, and it also has a built-in 6-axis IMU. Whereas the Nano BLE and BLE Sense, which is the one that you showed earlier, is quite interesting because it has a Cortex M4, so it's actually able to run things like TensorFlow and do some vision, very basic vision, and voice recognition based on TensorFlow. And at the same time, actually, the BLE Sense packs a lot of sensors. It has things like microphone, it has gesture recognition, ambient light, temperature, pressure, humidity, you name it. It's basically everything is there. Then we recently launched, last year, we launched the Portenta H7, which is basically a leap forward, because in this case, we are talking about the Cortex M7, backed with a lot of flash and RAM, and we also have a lot of other things like 2 secure elements, USB-C with DisplayPort. We have Bluetooth and Wi-Fi, Ethernet, CAN. I mean, basically, there's everything you may want to have in there. It's really, really small, and it's compatible with the MKR format. So you can also add the MKR shields that are existing there. And we just recently announced the Arduino Vision Shield, which takes advantage of the Portenta high-density connectors that bring out a lot of very interesting signals, such as the Ethernet, camera, and whatever else. So with this particular shield, you have 2 different configurations. One is with Ethernet, and the other one is with LoRa. But the most interesting thing is, of course, the camera, because with that, basically, we have added the possibility to do, let's say, vision applications. And we initially released that with OpenMV support, so MicroPython plus a number of vision-related libraries, along with TensorFlow and a lot of other stuff. Yeah, you get it. Also, it has a dual MEMS microphone. So basically, you can do voice recognition, and the dual microphone allows you to do beamforming. So that allows you to remove noise, ambient noise, and focus on the input you're interested in. And of course, it also has an SD card slot, which allows you to store things and do data logging. Even without it, you have a 16 megabyte internal flash in Portenta. So that's already quite a lot of stuff in it. Actually, the other interesting thing about the camera is that it is really, really low power, and it has a motion detection functionality that allows you to leave the camera on, pause the processor, and basically the camera will wake you up as soon as it detects motion. So that's really, really cool for low power applications. Then there is another product that we recently launched in 2 editions, one for the maker and one for the educational markets. So this particular one is for the maker, and it's called Opla IoT Kit. It's very cool because it integrates a number of sensors, and it also has a number of built-in sensors such as, again, humidity, pressure, gesture with light. And basically, it has this very cool circular LCD plus some touch buttons. And basically, the idea here is you can use that as a do-it-yourself home appliance. It's sort of the equivalent of a Nest, which is hackable and programmable. So there are a lot of experiments that you can start with, and basically, it can be also be battery powered and has a couple of relays, so you can control things like your heater, your watering a system or whatever. And of course, it is compatible with all of these boards. So this means that you can connect, well, in the kit, you get the Wi-Fi 1010, but actually, we are planning also to release this as a standalone carrier board that you can pair with whatever board you want. So if you want to have, I don't know, GSM connectivity, that's pretty straightforward. And I didn't mention that all of our products, all of our connected products have built-in secure elements. That's a key point here because basically we have crypto chips that not only allow you to store securely your secrets, But the most important thing is that as opposed to what happens when you store your secrets in the code, basically these are not, it's not absolutely possible to retrieve them, even by trying to delete the chip and do X-rays or whatever. So it's really, really important. And we recently also added secure over-the-air updates. So now with our cloud services, you can easily update the software on most of our boards. Then we have the Arduino SIM, which is also quite interesting because this is the same card you can pair with all of our, let's say, cellular modem-based boards. So both the GSM and the narrowband and the Cat-M1 modem. It has a very aggressive pricing in terms of data caps. And the other interesting thing is that it has a walled garden. So basically, you work within a fenced network. That means that the boards will not be reachable from the open internet. So it's an additional layer of security. Then we complement all of these products with the Arduino IoT Cloud. This is basically a service we have that allows you to quickly design your IoT applications. And the cool part of it is that, I mean, these kind of dashboards are quite common, but the good thing about it is that as soon as you're done designing your dashboard, actually the cloud software will automatically generate the software for the Arduino board. So the only thing you have to do is fill in the blanks in terms of reading the sensors. All the rest of the code is completely handled by the cloud itself. So of course you also have an application for your smartphones, so you can remotely check the sensors and actuate the actuators you have remotely. And of course, you have the possibility to handle your things, giving them names and let's say manage them remotely. And you have also directly in the cloud also the code editor, so that you don't need to install anything on your local PC. You can do everything from the cloud itself. And that's it from my side.
I've got a bunch of questions, but there is a Q&A section at the end, so we're going to ask those afterwards. Yeah, Robert,
yeah,
it's your turn.
I was actually going to say, I have a million questions as well. What the viewers come up with, but gosh, has the Arduino ecosystem evolved? I mean, I remember buying my first Arduino kit, like, you know, a long time ago, of course, right? You had the one board. You have like 20, 30, 40 boards now. It's crazy. So cool. Lots of different things to do. Thank you, Dario.
Thank you, guys.
Thank you, thank you. So we have our next guest here, someone I know personally very well. This is Rajan Mistry from Qualcomm. He's a senior engineer. And Rajan, welcome to IoT Central webinar.
Thanks, Robert. Thanks, Alessandro. Oh, by the way, Robert, I always have my Dragon Board 410C handy. Even though it's one of the first boards, I use it all the time. I use it for my projects all the time at home.
That's nice. You know, it's funny. I have one of the boards right here that was actually, this one was printed at the Qualcomm facility here in San Diego.
Yeah.
So yeah.
I have a red one, but it got stuck in the office. I couldn't get it on my way back home about a year ago. It seems like a year ago now.
Next time.
Yeah. Yeah.
Awesome. Well, welcome. The floor is yours.
Yeah. Thank you.
Rajan, we lost. Oh yeah, there we go. We lost your camera. Yeah, you're back.
So I know you guys talked a little bit about the difference between MCUs and MPUs. I wanted to also take this opportunity to kind of show how diverse IoT can be, and how all of these different use cases and dev kits for these different use cases can be different from each other, right? So I want to pick a few examples and a few verticals with Qualcomm SoCs, and talk about how each one is different from the other. So firstly, we have robotics as a use case, right? We have robotics development kits from Qualcomm, which are, for example, the Qualcomm Robotics RB5 development kit and RB3 development kit. And these are based on SoCs which come on the higher end of the spectrum in terms of compute power. These will have dedicated compute blocks like multi-core CPUs, DSPs, GPUs, mainly geared to help developers run their AI and ML workload on these SoCs and development kits. So, for example, these are based on QRP5165 or SDA845, which have Cortex-A based CPUs, multi-core CPUs on them. So that's robotics as a use case. Next up, we can have within IoT, camera as a use case. You have vision-based applications, whether that's digital signage or whether that's different development kits and SoCs. Once again, they will have dedicated ARM-based CPUs and different compute blocks to optimize some of the AI and ML workloads. Next up, we have connectivity options for development kits. So if developers are looking for SoCs which provide connectivity options like Bluetooth, Wi-Fi, Zigbee, Thread, and so on, you have SoCs from Qualcomm, like the QCA4020, that not only provide the connectivity for IoT devices, but they have the added advantage of having a dedicated application processor on them. So these will have something like a Cortex M4 on the SoC, so developers can run their own applications on the connectivity SoC instead of having to incorporate another MCU and MPU externally to run their applications. That will simplify the board design a lot. That will simplify the RF design a lot for their IoT designs and devices. Last but not the least, you have cellular modems from Qualcomm. These will have, this will maybe based on something like MDM 9205, 9206, 9207, and maybe some of the newer modems that provide cellular connectivity like 5G and 4G LTE for IoT devices. And these will also have a dedicated application processor, right? These will have something like a Cortex-A7 on them. Once again, where developers can use the Cortex-A7 to run their own applications on the modem instead of having to run something on an external AP. And in order to kind of enable the developers and enable all of these different use cases, we have really partnered heavily with the ecosystem of different hardware and software companies that not only build the development boards, but also provide like software services, enable developers to run and optimize their applications, and really take their proof of concept IoT device from that proof of concept to commercializing it and really seeing the scale of their design. So I want to really pick two of these examples and dive a little bit deeper into how these development kits kind of enable that ecosystem of use cases. And first one, I want to pick Qualcomm Robotics RB5 development kit, right? So we know we talked a little bit about the Dragon board 410C, but RB5 is a newer board with the 96 ports compatible form factor. And I know my friend Sahaj will talk a little bit more about 96 ports, but you can see the form factor really enables an ecosystem of different mezzanines. In case of RB5, you can have a vision mezzanine here. On vision mezzanine that's connected to a bunch of cameras that can take camera input and send it to the SoC. And SoC itself is actually a SOM that you can see at the bottom part. So you can have vision-based mezzanines, mezzanines with sensors on them, mezzanines for doing motor control for robotics, mezzanines which will provide communication in terms of 5G connectivity for your robotics project. And you can take all of this and you can really use the system on module SOM, or you can do your chip on board design and really use this as a platform, as a getting started point. But then you also have this ecosystem of SOMs, distribution channels to help you commercialize your design. The next example I want to use is the Qualcomm Home Hub 100 development kit. Again, when developers are looking to kind of evaluate different development boards for their IoT devices. They're looking for connectivity options. They're looking for something that kind of fits their project. And something like this, the development board has onboard sensors. It provides multiple connectivity options, Bluetooth, dual band Wi-Fi, 802.15.4, including Zigbee and Thread. And it also has different hardware interfaces for maybe your JTAG connectors, connecting Arduino shields on top of the development board. That they can really leverage that ecosystem of different hardware and software pieces to build their first piece, proof of concept. So when they're evaluating development boards, they're not just evaluating the hardware and the ecosystem of sensors, but also the software support for it, right? So in this case, it supports it has an ARM M4 for customer apps. So something like an ARM M4, you have ThreadX RTOS. You have free RTOS support for this particular QCA4020 development kit. What kind of IDEs does it support? For this one, there's an Eclipse-based IDEs that developers can use to really build their applications and debug their software within that IDE. And then it also comes with an SDK that has a whole bunch of sample apps for developers to get started. So they can really, it's a command line interface based sample app. They can flash the sample app, test out all the different features on the development kit on the SoC and see how all of it works. And then they can use that as an example, as a getting started point for their IoT projects. Also want to highlight how it kind of uses a daughter board. So it uses the Arduino connectors and connects to a daughter board, and the daughter board actually has a voice DSP on it that enables the voice UI features, right? So the underlying QCA4020 provides the connectivity options, and the daughter board really provides the voice features, so you can build your like home automation, hey Alexa, turn on my light sort of a home project or a DIY project, IoT project, and for you to get started. And of course, QCA4020 provides a bunch of security features as well. It has secure boot, it has a dedicated secure storage on board. It has a hardware crypto engine where you can encrypt your sensitive data and store it on the board. So once again, just to recap, as developers are looking for different development boards within the type of application that they are trying to do, I kind of feel these are all the different factors that they are evaluating, right? They are not just evaluating the hardware, although hardware and documentation is probably the first place where developers start. But in terms of hardware, component ecosystem, what kind of sensors you need, are they available regionally, different distribution channels, but also we encourage to strongly look at the software support for it, what type of operating systems it needs, what type of middleware support is available, whether there are libraries that the underlying SoC and the development kit can use to talk to the cloud service of your choice, right? So you want to talk to AWS IoT, you want to talk to Azure IoT services, whether those libraries are available and how easy it is to get started with those, whether there are sample apps available for it. And community support is critical for developers to get started and build their like first proof of concept. But really, that ecosystem of experts that will help developers to take the next step from their proof of concept, maybe do something like a system on module design, SOM design, or take it one level further, do a chip on board design, and have that support from the ecosystem of community where they can really commercialize their IoT devices. I think that is really critical when you are really picking out that even that first development kit, that's critical to kind of think through end-to-end what you are looking for. And I just wanted to leave the audience with a very big resource there, developer.qualcomm.com. We have a whole bunch of projects and resources for development kits with Qualcomm SoCs on them, and tools and resources for developers to download. And with that, I think I can send it back to you, David and Alessandro.
Yeah, Rajan, that's awesome. And I can actually vouch for that. Developer site is amazing. I've been using it for many years now, and Rajan, you and your teams have done a great job in building that out.
Yeah, thank you.
Yeah, thank you very much. Passing it back over to you, Alessandro.
Yeah, that was great. Thank you, Rajan. So now we've got Rick Bai from NXP, Senior IoT Solutions Marketing Manager. Welcome, Rick.
Hello.
Excited to hear your view on development boards.
Okay. Let me just fire up my screen.
I think we're right on schedule too, so this is going great.
Okay, so I'm going to talk about turnkey solution development kits versus traditional evaluation kits. So I think for certain applications, implementations, there's a problem with your traditional general purpose evaluation kits. I mean, pretty much every MCU and MPU EVK that comes out is intended to support a wide variety of applications. And these kits, the hardware platforms, literally include everything that the product manager can think of, including the kitchen sink. It's the same with the software development kits as well. They include drivers for everything, and there's a ton of code for the developer to wade through. But there are some key things that are missing, and that may be some third-party IP that the silicon vendor doesn't provide, third-party IP that's needed for many of the apps that developers are trying to enable. So what you end up with is an EVK and its SDK that makes it pretty difficult for developers to build their application, and also for engineers to design their boards to fit into the form factor of the products that they're targeting. And this all results in a long time to market and a long time to revenue. And that's bad, obviously, for the developer, the OEM, trying to get a product to market, but it's also bad for us as semiconductor vendors because we want to see our products get to market as quickly as possible. So, I mean, you can't really fit a design like this. This is a voice recognition board. If you want to build voice into a light switch, this isn't really a good form factor that lends itself well to imagining how you're going to build it into a light switch. But if you've got something like this, similar, the same functionality, actually this is a complete Alexa built-in solution. This is a light switch size, so it's pretty trivial to go from this to a light switch. So what we're doing at NXP in our IoT solutions team, of course, we still, our colleagues who are responsible for all of our MPUs and MCUs are still churning out these boards with all of these standard EVKs with all of their processors and MCUs, because that's what developers typically need to get started with to evaluate a platform. But once a developer's thinking about something more targeted, then maybe they need a more targeted development board. So that's what we're doing in NXP's IoT solutions team. We're doing application-specific development kits that are much more turnkey solutions where we're delivering hardware that's a near production-ready design, that's cost and form factor optimized for the application we're targeting. And not only that, it's been FCC certified at a minimum for RF, but potentially also tested in other ways. For example, I mentioned our solution for Alexa. Of course, that's been qualified by Amazon so that developers that base product designs on that development kit will know that it'll be easy for them to certify their kit. And although this session is all about development kits, you're thinking about hardware, really it's all about software. That's the far more important piece of this puzzle here, because without software, all you have is something warming the room, or maybe not that much if it's a low power MCU, but it's not doing anything useful until you bring the software. And that could be the biggest challenge. I've seen many vendors that do have application targeted development kits, but it's a real challenge to pull all the software together. You've got to download an SDK from the silicon vendor, and then you've got to go and negotiate a license agreement with a third party over here to get their software and download it and integrate it. Do the same thing with a second third party over there. You may have to get something from Amazon or Google or whoever, and it can take days, if not weeks, before you can even bring up the development kit and get it to do what you want it to do, what it says on the box. What we're doing is cutting through all that, and we're delivering our development kits with pre-integrated production-ready software bundled with all of the third-party intellectual property. It's been fully tested, certified and qualified as applicable, as I said earlier, and everything is provided in source code, except of course the third-party IP. It's usually a black box with APIs. So what we're doing is we're providing a one-stop shop for developers. Everything comes from NXP, even if some of it was sourced by someone else. We're reselling it. We've negotiated the license agreement. We're managing all of the support. And most importantly of all, out of the box, it does what it says on the box. You literally plug in the kits. Like this kit here is our face recognition kit. You plug it in and it immediately starts trying to recognize faces. There's no weeks or days of downloading software and building images, etc. It just works. And of course, the whole intent of this is to simplify hardware and, more importantly, software design to enable a quick time to market. So our team has done this with for a number of applications for face recognition and for voice control. I'll talk about the kits we have in the market on my next slide, but this is just a bit more detail about what we provide. So we talked about the hardware, cost and form factor optimized, pre-integrated production ready software, everything you want. So you get the kits, you get source code, you get schematics, you get layout, you get bill of materials, you get extensive documentation, and of course you get all the certification, plug it in, and it works. So our team, our original goal was to deliver ML AI solutions that operated at the edge to minimize latency and do as much as possible without relying on the cloud for applications like face recognition and voice control, and do that on microcontrollers and application processors or MPUs. Oh, and by the way, I'm glad that we've had this discussion about the difference between MCUs and MPUs, because it's not a silly thing to talk about. A lot of people have that question. And again, I think it comes back to software. If it can run a complex OS like Linux, Android, Microsoft Windows, then it is an MPU, and it needs virtual memory support, and it's got a memory management unit. But if it can't run an OS like that, if it just runs an RTOS or it's a bare metal implementation, then it's going to be a microcontroller. It doesn't have a memory management unit. And something missing here. So most IoT devices, originally IoT devices, we were thinking of them as dumb sensors that had connectivity to the cloud, and all the processing was done in the cloud, little or nothing at the edge. But that's changed over the last few years. And now with ARM delivering the Cortex M7 core, NXP's got it running at 600 megahertz with pre-announced gigahertz versions of these devices. You've got a phenomenal processing capability at the edge that you can leverage to deliver low latency ML AI implementations. So what I was saying earlier is we've originally planned to do this on MPUs and MCUs, but we've just kind of spent all of our time leveraging the phenomenal power that you get with an RTOS platform, leveraging the M7 running at 600 megahertz going on to a gigahertz, delivering capabilities like voice control, both offline, local voice control with phrase spotters. Probably in the near future, we'll have natural language understanding that can run entirely on an MCU. Also Alexa, Amazon has launched about a year ago the Alexa for IoT service that now enables an MCU to be used as the client instead of an MPU. And this is enabling OEMs to build Alexa into things like light switches. And then finally, delivering face recognition, running on an MCU with liveness detection now. So you can have a secure implementation, and you can put this into into some things like battery-powered door locks. You can't imagine putting this into a door lock, can you? So, so what we're all about is making these complex IoT challenges for machine learning implementations of voice and vision, making them simple, enabling our customers, developers, to focus on what they do best: building a light switch, building a door lock, building a washing machine, etc., and delivering to them capabilities like voice and audio and machine vision and face recognition capabilities they're completely unfamiliar with. They don't need to have any experience in those areas, because we're delivering something that's very much turnkey and enables them to get that into their products as quickly as possible, try out the market, and if it's successful, then maybe developers will want to get some of that expertise in-house and require less of a turnkey solution. And oh, by the way, we can support that as well. But just to try the market out, to get to market as quickly as possible, we're delivering something on a productized, optimized, integrated solution. So I think with that, I'll hand it over to 96 Boards. Thank you.
Thank you, Rick. That was awesome. I mean, you just proved, to all the people that didn't believe in the fact that tiny devices, Cortex-Ms, could run, machine learning workloads, inference on the edge. You just proved that it's possible, right? And I'm thankful for that, because having all these different platforms that you just showed is what a lot of people are looking for, right? And the capabilities of these devices are quite outstanding, actually. So thank you for showing that and sharing that. I wanted to remind all viewers that if you've got any questions for any of the panelists, you can ask them on the bar that you've got on the side. We've seen some questions come through. We'll answer them in a few minutes. So just keep on asking questions if you've got any questions, and we'll relate them to the speakers soon. Robert, take it away.
Excellent. Awesome. And yeah, thank you. I want to also echo that. Thank you very much from Rick and at NXP for that presentation. Next up is Sahaj Sarup from 96 Boards. He's an applications engineer from 96 Boards, also a very close friend of mine, and I've worked with him very closely for the last several years. Sahaj, very excited to have you here. Please, if you could just take it away. Excited to hear about 96 Boards.
Thanks, Robert. Hello, everyone. So let's talk about 96 Boards a little bit. As you can see, 96 Boards, the only SOC independent open platform. Let's talk about what that actually means. 96 Boards is an organization that maintains a lot of specifications. These specifications guide how a 96 Boards development board is built, and make sure that all the development boards are compatible with each other. They follow the same layout, they follow the same pinout, they follow certain guidelines that help them fit into a similar size casing and stuff like that. And we'll go into the detail of that very soon. We are SOC agnostic, so we don't care what SoC it's on there. We support everyone as long as you follow our steps and our guidelines. We are free to provide any sort of support, forums, a place for your documentation, a website, and all of that good stuff. We are supported largely by Linaro, that is our parent company, and their member ecosystem. So a lot of engineers within Linaro that are doing SoC bring-ups and OS bring-ups do use our boards, and we'll look into that just in a bit. And so here's a bunch of platforms that we support. So AOSP is a big supporter of 96 Boards. A lot of our boards are upstreamed in Android and directly supported by Google. Automotive grade Linux, Zephyr, RTOS, AWS, and DB14C that you guys saw with Robert and Rajan a while back, that has AWS and Azure stuff, projects built while it was still very active. And some trusted Opti and T trusted platforms and stuff like that. So quickly moving on. Specification. So this is sort of the big part of 96 Boards. We have different specifications that detail the board layout. I'll just quickly go through all of these, and then I'll have actually some cool boards to show off. 96 Boards consumer spec is your run-of-the-mill small form factor single board computer. That gives you mezzanine headers. That's our extension board form factor, and then your HDMI, USB, and standardized power delivery system using parallel jack. It's mostly targeted towards mobile grade SoCs to desktop or even certain industrial grade SoCs, and it's really built to cost as much as possible. Also, sometimes if you're opting for stuff like FPGAs and even very high-end mobile grade SoCs, things can get a bit expensive, but they're never too atrociously expensive on the consumer boards side. The enterprise spec is completely opposite. It's not built to size. These are large boards. They have enterprise grade or server grade SoCs a lot of the times, and the power envelope is much higher. The price envelope is much higher, but also gives you a lot of performance or gives you a lot of flexibility, and that's mostly used by build farms or SOC evaluation and server grade deployment and stuff like that. IoT edition is mostly for Cortex-M and Cortex-R processors, the real-time stuff. We have a certain number of boards with Cortex-A processors, but that's just to fit it in a smaller use case. Sorry, a smaller form factor. But yes, these are low power consuming, cheap IoT boards that you can just deploy and forget, stuff like that. So I'll show more boards. We have two new specs called the SOMs. The first one is the SOM spec. This is again our system on module specification. We have a few products out, but we are also gearing up to do a bigger launch and having more partners on board. I have one of the boards here, so I'll show that quickly in a bit. 96 boards automotive grade, that's the most recently released specification that targets SoCs and MCUs that are very specifically created for automotive workloads. And you will have all the ports that are used on automotive grade use cases and functionalities such as in-vehicle infotainment, ADAS, autonomous driving, and stuff like that. So compliance is the biggest part, how we regulate what goes onto a board and how a board looks. We go through a lot of testing, a lot of evaluation. So before launching, vendor will provide us a board that will and then engineers like me will go through that board and make sure that everything meets the standards, the pinout is correct, the placement of the ports is correct, and everything snaps together. And once that is done, you can actually get your 96 board certification and market your product as a 96 boards compatible product. You can see the rejected board there. If you look very closely, it has the two IO ports swapped, and so it got rejected. And believe it or not, that's an actual use case that happened. But yeah, so that's how that's the compliance is the gatekeeper to make sure that all the boards are nice and compatible with each other. So the way 96 boards work is that we have a steering committee first, and they decide on what goes into the set specification document. We are always evolving, so we have regular meeting with our steering committee that decide either on the software side or on the hardware side what actually goes into the specification and the requirements depending upon what market segment they are trying to target and what the consumers or different makers and developers want from the development boards. Then we have our manufacturing partners. These people actually take the specification and they have good contacts with the SOC vendors, and they marry both of those things together to create a 96 boards and then market them. And we have our partners, and they are usually involved in creating mezzanines, and which we'll get to in a bit. So let's take a quick look at our products. We have the 96 boards consumer product. I have the RB3 with me, which is a very good example that Rajan also showed of the 96 boards consumer spec. So as long as you follow documentation, you can play around with it quite a bit. So one of the interesting approaches they did was to put one of their SOM at the bottom, and then at the top they have extra headers. We have no issues with that as long as you follow the base 96 board spec. You are free to do everything, and they decided to make a 2-board layout, so that's fine. And that's how we are flexible. You don't have to be very strict to the base board design. We don't specify where the SoC should be, or we just need the base pinouts to be correct. We have a bit more extension to the CE spec called the CE spec extended, which was the Thor 96 and the AI ML boards you saw there, and that allows board designers to have a bit of fun. So each of these boards have the base CE design and then a bit of an extended area. And what that allows is to play with it. So for the AIML, they decided to add a LTE modem slot, which is the standard PCIe slot, but only the USB is populated on this space that was available. And on the other board, you get a HDMI port, an extra HDMI port apart from the one that's already in the spec. So and a couple of audio jacks as well. So that allows a bit of variation within the standard CE specification. And then we have the 96 boards enterprise grade. So these are mostly industrial grade SoCs. I have the Oxalis right here. It is based on the LS1012A and from NXP, and that one is a networking chip. And you can have a nice large board design, and they have dual gigabit Ethernet and other fun stuff like that on board, and a PCI slot at the back. So that's the enterprise spec. And on the IoT edition, again, that's IV 5. That's an IV board, and that's for Bluetooth and Wi-Fi enablement. And we have on this little solar panel car I built a while back. That's the 96 volts carbon. So those are both examples of IoT edition boards, very low power and mostly based around MCUs. Moving along, again, as I said, we are SOC independent, and we have a bunch of stuff here that lays out. We have FPGAs, we have Qualcomm processors, we have high silicon processors, Action Semi, even some Intel, that's the Altera part, and some ASIC stuff like from Sophon Edge, which is an AI ASIC basically. So so as you can see, much variation in the terms of power, processing power, the type of processing it's meant to do, and vendors, but it's all on the same form factor. It looks almost exactly the same. You can put it in the same case, and you can have mezzanines attached to all of them in the same way. And that brings us to mezzanines. What are mezzanines? They are tiny, they are small form factor extension boards. So on the base, we have the Dragon Board 14C. Above that, we have the audio mezzanine that spits out audio from the back. Right here, you can see the audio jack. And on top of that, we have the 4G LTE mezzanine. So the mezzanine ecosystem is meant to be stackable as long as the pins aren't reused, apart from like stuff like I2C, which can be reused. So this stack actually works, and a few of our manufacturers are committed to stackability, and they've gone to 5 or 6 board stacks that have worked perfectly fine. So yeah, this gives you functionality of having audio out from the SoC, and also have some groove connectors for expansion, and also have an LTE connection. So you can sandwich stuff like that and just add functionality to your boards. So the mezzanine standard basically follows the CE pinout, and yeah, there's not a whole lot of specification to it. You can go very wild with it. You can create an entire drone that's a mezzanine itself, and that's actually a project that had been discussed a while back. So yeah, these allow you a bunch of flexibility. One of the mezzanines that you can see is actually on the with the 4 RJ45 ports is sort of a play where they didn't use the standard IO, and they basically brought out, because it's an FPGA under there, they brought out the all the 4 Ethernet IO directly from the FPGA pins. So yeah, a bunch more mezzanines and use cases out there. We have a few initiatives that will go through. The 96 boards AI is a collection of boards from across our other specification that are good at doing AI, whether they have DSPs on board, whether they are FPGAs, or whether they have other ML hardware built into them. The automotive grade initiative is encompasses anything that has to do with automotive compute, whether it's ROS, whether it's the work we are doing on with AutoWare, and even if it's a drone that captures paths from or maps buildings and stuff like that from to be used on automotive map. In that case, we are considering that in a part of the automotive initiative. Then we have the mezzanine community. This is a small group of people who get together, discuss new mezzanine ideas, how we can extend the platform, and also provide an open source also provide a repository to host open source mezzanine designs. And we've had quite a lot of new ones going around lately. So you can follow that GitHub link to go to that particular repository and check that out. So towards the end, our channels and our resources, we have our forums, we are on Discord and IRC, and you can just use all of these links, and I'll make sure this PDF is available later to check us out at different places. Our website and our documentations are open source, so if you feel you have the need to change something or improve, just let us know, ping up as an issue, or even create a pull request. We are happy to include your bits into our website. And that's, I guess, about it. Thank you, everyone.
96 boards, everyone. Woo! Yeah, so awesome. Thank you, Sahaj, very much. Very cool presentation. And so now I guess, Alessandro, what's next? What do we have on the docket?
Yeah, we got Q&A. I just wanted to say that we are at the top of the hour. We are at the top of the hour. So I just wanted to mention to everyone that needs to go somewhere else, has other appointments, that we're going to have a recording. It's going to be live 48 hours after this, so on Thursday. So if if you got to go, thank you very much for watching. Otherwise, we'll take questions now. So we'll take about 10 minutes of questions. So yeah, I see everyone rejoining on camera. We're missing Dario only, and then we'll get started. There we go. We got everyone. Welcome back, everyone. Thank you all for the presentation. It was great to see all the different boards in all these different ecosystems. Cool. So the first question from the audience is to Arduino. So the Arduino Vision Shield, I guess you mentioned the Arduino Vision Shield, and they're asking about what is the highest and lowest temperature the device can work in, and what is the highest lowest relative humidity capability that the device has. Any insights on that, Dario?
Yeah, in general, the products we are handling for the Pro Business Unit are -40 plus 85. For the Vision Shield, I think that also is the case. I need to double check, honestly, because I don't remember exactly the data for the particular camera. But the good news is that we have all of this data in datasheets that we are publishing shortly on our website. So, I mean, you will find everything in there in a short while.
Great. All right. Thank you. Hopefully that answers users' questions or the viewer's question. Let's move on to another question here. And this one is for Rajan from Qualcomm. This is going to be two questions in one, because I think the first part's pretty easy to answer for you. When you were going over that home kit, one of the viewers wanted to know if that was Bluetooth 5.0. Is that a good?
Yes.
Okay, perfect. That answers that question. And then this will go on right to this next one here. So one of the viewers asks, I noticed the Qualcomm SDK natively supports free RTOS. Can we expect the same for Zephyr?
So that question is not for me, right? Is that question for?
It came up when you were talking, so that's why I kind of put it under your category here. I mean, if there's a
so it's the QCA 4020 development kit supports ThreadX and FreeRTOS, and the way that works is the SDK, you can basically compile your applications using one of the two RTOSes. Zephyr right now is not part of that SDK. I'm not entirely sure if that's part of the plans for that particular SDK, But right now, out of the box, Redux and FreeRTOS are two that particular SDK supports, and it will differ for other SDKs. Like I mentioned, there are different development kits for different SoCs. Each SoC has a different SDK associated with it. Some of the MDM SoCs have support for other RTOSs to begin with. So it gets a little bit complicated when you are talking about IoT and all of these different use cases and all of these different development kits. But highly encouraged to go look at the documentation. Like Dario was also saying, it'll be in the documentation. We have community forums as well. You can post a question there, and somebody who is actually hands-on working with that development kit can answer that question better, probably.
Awesome. Thank you for that, Rick. Rajan.
Yeah.
I was thinking of Rick because the next question is for Rick, actually. So, Rick, you mentioned about all these turnkey solutions. We've got a viewer asking about what security those devices contain. I don't know if you've got any details right now, or if there's anywhere where people can find more information on that.
Yeah, so these solutions are all built on FreeRTOS, like Rajan's 4020 solution. And we're leveraging all the capabilities that Amazon has included in FreeRTOS. But yeah, beyond that, we have offered in the past a secure element in these designs as well, but we haven't seen a lot of take up of that level of security today. But if you need more details, I can follow up on specifics on what we do have on our kits regarding connectivity and security.
Thank you.
Oh gosh, I have so many good 96 boards questions here that came up. Okay, so let's go with this one first. Hopefully, we'll see if we have a time to go through all the panelists here again one more time through. This one is asking, and again, this one is from one of our attendees, one of our viewers. Are any 96 boards automotive boards compatible with Android Automotive? Which boards do you recommend to use Android Automotive?
So we haven't really released any boards on the automotive grade spec yet. It's still a work in progress. But if you're Google, if you're strong at Googling, then I guess you can find something about it there, because there's some documentation that's already opened up. But as of now, a lot of our Android or ASP workloads being moved to the RB3, and that's what's being developed upstream as well with the Linaro Consumer Group. So if you have the knowledge, you can actually just enable Android Auto builds for it. We don't currently build or support provide Android Auto images, but it's not a it's a trivial task. You can do it easily. So I think the RB3 would be the best candidate at this point.
Cool, thank you.
Awesome. Cool. So I've got two questions for you, Dario. One is more hardware, one is more software. Okay. So maybe we could do a quick kind of, maybe we could take them both quickly. So they're kind of disconnected, but I'm curious. We've got two people in the audience asking these two questions, so I'm keen to cover them both. So the first one is on the hardware. You mentioned that a lot of the boards, the Arduino boards, have got security elements. So I wanted you to kind of cover that a bit more, talk about maybe the security features that Arduino exposes, or the capabilities that it's got. And on the other hand, software wise, a viewer is asking about the Mbed OS running underneath Arduino. I wanted you to kind of maybe cover that as well, and talk about how that is, how the architecture there works.
Okay, I'll try to be quick. Also, the questions are pretty complex. So in terms of security, all of our connected boards have secure elements. So basically, the MKR family has secure elements from Microchip, which provide strong support for TLS and storage for certificates. that's what we use in order to authenticate with Arduino IoT Cloud, but these are not pre-provisioned. So everyone is free to provision them with whatever kind of certificates they like, even if eventually we can also provide them pre-provisioned with, let's say, trusted certification authority certificates, so that they can be compatible with any cloud. On Portenta, we raised the bar, and we added also the NXP SE050, which is much stronger. It handles, let's say, more security algorithms, and it has a lot more storage. So on that one, we are going to have a number of libraries that support that in order to enable stronger security and more interesting use cases. Of course, all of the new devices, so M4 and M7 boards, so basically at the moment is the Nano 33 BLE and BLE Sense and Portenta run on top of Embed. So that's a breakthrough that we had when we launched the Nano 33 BLE. And that's interesting because, first of all, we use Embed as a sort of abstraction layer. So this allows us to run Arduino on top of every Embed supported board with a, let's say, just with a click of a mouse. And the other thing is that thanks to this, we will be shortly introducing multitasking within Arduino. And that's also a very interesting point, because with multitasking, we will also be leveraging low power, of course. So that's one important topic that must be outlined for all these projects.
Thank you very much for that answer.
Sure.
Thank you for being quick.
So I don't know. Should we clear this? Do we have to clear this? Do we have more time for questions? I think we can go one more round. But
yeah, let's finish the round. You're up.
One more. Okay, one more round. Here we go. So Rajan from Qualcomm, have one for you. I'm really curious here because I know you guys have so much cool stuff going on at Qualcomm. What kind of stuff are the engineers? And this again, like, you know, touching on that whole sweet spot for single board computers and developer kits and things like this. What kind of stuff are engineers and developers at Qualcomm doing with these boards? And what kind of stuff, maybe if you want to also touch on, what kind of stuff have you been working on with some of these developer boards?
Yeah, thanks, Robert. I personally have been working on the robotics projects, Qualcomm RB5, kind of integrating with the development kit with Turtlebot, kind of doing some cool projects on that board. But in terms of what other engineers are doing, I think it's pretty hard to gauge that now that everybody is working from home. And it's about a year ago. I mean, internally, I've seen a lot of engineers do like cool projects with these development boards, like the Dragon Board 410C, setting up cameras in ping pong rooms, trying to kind of figure out when the table is free so that they can actually go and play ping pong and nobody is there. But now that that's no longer an option, right? So I've kind of lost visibility to that for over a year now. But yeah, I do still get requests from a lot of engineers internally to get their hands on the Dragon Board 410C to kind of test a few things out, maybe test some sensors out, kind of integrate some stuff on the software stack and whatnot. But yeah, just in general, just having, I use Dragon Board 410C a lot also for simple things, right? So there are tools in the SDK which can run on a Linux based OS, right? So I can run the Linux on these boards. So just quick and simple tools to run some SDKs, run some servers, run some things to download certificates and things like that. It's pretty handy to have these boards around.
Yeah, new documentation and projects and cool stuff keeps popping up on your developer network website too. So yeah, great, thank you.
Yeah, for RB5 especially, I think we've made a dedicated effort to make sure documentation is more open and accessible to developers, and even the software stack for that robotics platform, especially optimizing the algorithms, right? It's whether you have a AI model using TF Lite, or you're optimizing it using Qualcomm's tools, like how you would end up running those on the kits. We have detailed documentation on how to do that, and that's open for developers to kind of check out on developer.qualcomm.com.
I ordered some RB5s. I hope they show up soon. I have my RB3 here on my desk, but I'm waiting for those RB5s to show up. So yeah, awesome.
I got some towards the end of last week. I need to go and distribute them now internally to all the other guys.
I live right down the street, so feel free to choose on over.
Awesome. Thank you, Rajan. Rick, another question for you. Actually, I ask you, as Robert did before, I ask you a really quick one that I think you'll be able to answer quickly, and then another one. So it's a combination of two questions. So the first one is, has there been a collaboration with Microsoft as an alternative to Alexa? One viewer is asking. And the second question is, what use cases are you mostly seeing using your turnkey solutions?
Yes, so with regard to Microsoft, there's nothing going on with Cortana. I'm not sure they've got an implementation of Cortana that can be used with an MCU in the way that Amazon has enabled Alexa to be used with an MCU-based client. Regarding use cases, for voice control, we're seeing that being built into a wide variety of devices. For Alexa, it's more like smart home and smart appliance devices, things like light switches and kitchen appliances, anywhere where you can get an Echo speaker off the countertop and clean up the look because it's embedded in something else, or put Alexa in the closet, the powder room, etc., which you can do with the light switch. For the offline local voice control, we're seeing, particularly with COVID now, we're seeing a lot of people want to implement hands-free, touchless user interfaces, and speech is a great way to do that. So for things like elevators, vending machines, and for face recognition, I think the initial application has been primarily smart locks, as I mentioned during my presentation. That's why we recently added liveness detection implemented with extremely low-cost CMOS sensors. But extending that touchless user interface paradigm even further, we're getting a lot of interest now in combining face recognition and voice control into one implementation, so you can use your face for authentication and then communicate with the device to get whatever you want out of it. And as a plug,
awesome.
We've got a website called NXP Live, which is kind of an extension of CES with lots of demos. And there are some demos of the things I talked about online there, virtual demos, including a virtual demo of this smart touchless HMI that I mentioned. So you can see a use case for that.
Cool, thank you.
Awesome. Okay, here we go. This might be the last one, Sahaj. So let's make it count. Here is one from another viewer, and they are asking, are some of the 96 boards IoT edition optimized for low power states? What about other generic kit boards?
Low power states, that's an interesting one, because anything that has BLE will have one. One of the interesting use cases I have of the Carbon, where it has two separate chips, one's an STM32, the other's an RF. So you can basically put the STM32 into low power mode and just an RF have active BLE connection. For some of the other stuff, Zephyr handles a lot of it on most of our MCUs. And if that's enabled in SoC, that will work. The other example is usually with IMX8 boards, where they have an M4 and Cortex-A part, and you can actually put the Cortex-A part to full sleep mode, and then have the Cortex-M4 part wake it up whenever that's required. So yeah, those are sort of what I'll call putting things in low power mode.
Excellent. All right. Well, I think that covers it all, right, Alessandro?
Yeah, I think we're coming to an end. It was a pleasure to have everyone on, and I just wanted, before handing it over to IoT Central, I wanted to say a big thank you to IoT Central for hosting this, and obviously a big thank to all the guests. I mean, it was amazing to hear from all of you, and I'm sure that we could go on for this, maybe for another whole day, because there's a lot of questions still coming in. But yeah, thank you to all the guests and to all our amazing viewers.
And I would like to echo that as well. Thank you to the guests. Thank you to the viewers. Thank you to IoT Central, David, and all the folks over there. And also like to let everyone know that Alessandro and we both host a live stream every week. So please feel free to check out at ARM Software Developers on YouTube. You'll find us there. We have some fun doing stuff like this on a weekly basis. So thank you.
Alessandro and Robert, thank you. So I'd especially like to thank our hosts and panelists, and a special thank you to ARM. As a reminder, a recording of this roundtable will be available for viewing on iotcentral.io on Thursday. Be sure to take a look for more webinars and roundtables from IoT Central. This concludes today's roundtable. Thank you for attending.